All right, folks. We're on video number 6 or 7. Something crazy. Sorry, I got tic-tac. Jeez. Fun one today. Exponents. Exponents. We did a little bit of this, but really not a lot. So this one might be a little different. We're going to go through all the exponent rules, remind ourselves how exponents work. And then we'll do some example problems. This one, I don't have anything written up, but some of these are going to be really easy, so we'll do that. Product rule, real simple. If we have something like x squared times x to the third, that becomes x to the fifth. We add the exponents, okay? If you have two things that have exponents that are being multiplied, okay, that's the key, they're being multiplied, you add them together, right? So if we had y to the 10th times, it's got to be a times y to the 5th, that gives us y to the 15th. Okay? If things are being multiplied, you add them together. Now, if you have something like this, y squared plus y to the third, we cannot do anything with those. Okay? That is as far as we can go. You cannot combine those in any way. All right? So this needs to be multiplication, and then you add the exponents. I know that seems a little weird, but if you're multiplying two things, that you add their exponents. And they got to be the same variable, right? So, but if you could also do this with real numbers, like in your example, you got some of these examples in your, you had 2 to the 4th times 2 to the 2nd, right? That gives you 2 to the 6th. You can do it with numbers, but it's got to be a 2. We can't do this if we have 3 squared times 4 squared. That doesn't, obviously that doesn't work, okay? Okay, so that's the product rule. Product. Got to get that product. Quotient rule, we subtract, right? So if we had x to the 5th over x squared, you subtract if they're being divided, right? And that makes a ton of sense, right? And we get x to the 3rd. Now, we want to try to keep the exponents positive, okay? So if we had let's do another one. If we had x to the 3rd over x to the 10th, we want to keep the exponents positive. So in this case, we subtract the bottom, okay? You could do 3 minus 10 and get x to the negative 7th, but you want to keep these exponents positive. So we're going to get 1 over x to the 7th. Okay, I dropped this guy down and subtracted. Okay, so whenever your exponent changes, if it's on the top or the bottom, it changes sign. So for example, if we have x to the negative 3rd, that becomes, and I think this comes up later, but now it seems like a good time to talk through it. That becomes 1 over x to the positive 3. Okay? Following me? Following me? So if you have the bigger exponent on bottom, bring the little one down and subtract it. Okay, quotient rule. Zero exponent rule. This one's super easy too. Anything to the 0. So if we have z to the 0, that's 1. If we have x to the 0, that's 1. If we have 2 to the 0, that equals 1. Anything to the 0 exponent is 1. Okay? Not 0. It's 1. All right, that one's easy. Next up, power rule. The power rule. So if we have x to the 3rd in parentheses that squared, now we multiply them. Okay, so now this is x to the 6th, not x to the 5th. So if it's squared, that's how it goes. Let's see, what else do we got here? So yeah, if you had multiple things in there, so let's say when we did do something like this in class at some point, we had 2x to the 4th, the whole thing to the 4th, we get 2 to the 4th and x to the 4th. So we distribute that exponent. And if it was 2 squared x squared to the 4th, then we get 2 to the 8th, because again, we multiply, and x to the 8th. Okay, let's see. Is there any other examples we want to sit there? Same thing if we got a fraction. Let's do one more. We'll change colors so you can see it. Say we had x squared over y to the 3rd, and we did that to the 2nd power. This would become x to the 4th over y to the 6th, okay? So even if you got something on bottom, still distribute that exponent, all right? I think that's pretty good. Okay, and then we already talked about this a little bit, but negative exponents, see if I'm missing anything. You got x to the negative 3rd, that becomes 1 over x to the 3rd, because you want to keep it positive. You want your exponents to be positive. Let's say we did something to a negative exponent. So let's say we had, let's put a number in there. Let's say 3 to the negative 2, x to the positive 2, and then y to the negative 3rd. And we're going to multiply that to the negative 3, okay? What we're going to want to do is distribute this. So we get 3, negative 2 times negative 3 is positive 6. X is negative 6. And then y is positive 9. Okay, but then now we're not done simplifying because we got a negative exponent. So really what we want to say for this is 3 to the 6th times y to the 9th over x to the 6th. We want to bring the x down and make it positive, okay? We want to bring that x down and make it positive. Okay, so you might have something crazy like that with a negative exponent where you distribute and then you got to simplify because we want all our exponents to be positive. I think that's a good kind of, those are kind of our main rules. And now maybe we do an example or something. I'm looking at your little worksheet here. And find some good examples to do here. All right. Let's get it started. So we could have something simply like a squared, whoa, that freaked out, to a to the whatever, do another square, let's do something to the 4th. Okay, these are all being multiplied. They're all in A, so we can just add all these up. So 2 plus 3 plus 2 plus 4. So what's that? 11. So this would just be A to the 11th, okay? So you could do something simple like that. We could have something more, let's see, what's trickier? I mean, again, we've seen these already a little bit. 4x squared, y to the 3rd, z to the 5th. And let's square it all. So we'd get 4 squared. If you want to put 16 there, you could. We get x to the 4th, y to the 6th, z to the 10th. Okay, so we could do something like that. Let's do something a little crazier. You've got a bunch of problems on here. These are not that interesting. Let's do something with some fractions. Okay, let's say we had this. Okay, and then let's say we had x to the 5th on the bottom, y to the 2nd, and then we want to cube this whole thing. Let's put some on the bottom too. Just put a 2 down there. Okay. First, before you cube anything, it's probably smart to simplify in your fraction. Okay, we're going to leave the numbers in the same place, but we can move this x down and this y up. Right, so we should get -3. Keep the -3. And negative sign is super aggressive. Sorry about that. But we're going to move the y up. So it's y to the 5 over y to the 2. So that becomes y to the 3. Okay, and then the x, the bigger one's on the bottom, so we're going to move this x down, and so we get 2x to the 3. See how we're simplifying those? And then we're going to cube the whole thing. Whoops, that's a square. We're going to cube the whole thing, and we're going to get -3 cubed y to the 9th over 2 cubed x to the 9th. So that might be how you solve something like that. Okay, where you got a big fraction, you're squaring everything. Otherwise, your guys' problems don't look too bad. It's kind of going through, and there's one you got to FOIL. There's some division ones, but it's not too bad. You can probably roll through even all those examples we did. So there we go. We got another one in the books, guys. A little reminder on how to do exponents, move them up and down all around. And I hope that's great for you. It's been great seeing you. Hope you have a great day.